In this work, we try to kind of look at it from two perspectives. How do we make the soil data available, usable by the farmers, and of course, improve the quality and spatial distribution of the data? So in this study, we use a participatory approach. This chart here shows the steps that we followed in terms of how to execute the mapping process and of course the end product. But the first step was that we downloaded satellite imageries of the study area. Then we took that to the next step, which of course at this village level, we interacted with the farmers where they drew the boundary of the village on the map itself. And of course, they also delineated the possible soil units that they have within the village using their own local systems. You can see from this map, this is a map that was generated eventually where they talk about the different soil types and their spatial distribution based on their own perspective. Now they have 4 types of soils. You have Baaduni, Jaaleri, Loope, and Taaduni. That's their local system of soil classification. So what we now did is that we went to the field with them and then we located some kind of profile pits within each of those units, which is now what you see here in terms of the soil profiles to kind of get modern data overlaid on their local system. As the next step to kind of make it much more spatial in nature, we use the gamma spectrometry. Well, when I went to the field using a flexible grid to kind of pick gamma spectrometry data throughout the village, which is what you see on this map wherever we sample. As the next step, we use cluster analysis to kind of group this data into units of possible soil types, which is what you see here with the clusters representing possibly different types of soils on this slide. The next step was now, in combination with this gamma spectrometry clusters and then elevation data, and of course the soil data we collected from the field, we're able to generate soil map of the area, which is still in line with this, which is the local one, and then the one we generate using modern up-to-date information and gamma spectrometry, which is this. You have much more details, much more precision, and much more usability. But then the next step, we have some soils we collected, which we'll analyze and then kind of find out which units need to be merged and which units need to be left distinct as they are. But we need to kind of overlay that data on it, and eventually we'll now come back to the village, present it to the local villagers, and then assess the quality. But then the next step is that they will now tell us based on that, because the map itself may not really be useful because potassium, nitrogen, that's not what they need. They might need land stability. So what crops do they grow? Which ones do they want to assess? We'll now go back, get the land stability, and then present back to them as a final product. In conclusion, I'll say that gamma spectrometry is a very important tool in areas where data is not really that much available. And of course, you don't have much funds because it's relatively cheap and easy to use. So as can be seen here, if it's combined with topography data, soil data, and petrography, it gives good quality soil information even at the local village level. In conclusion, I would say that the farmers need to be involved in the process right from the beginning to the end, particularly in the end where you now need to readapt that data to make it useful to the target audience, which is the local farmers, and make it kind of something that they can easily interact with the extension agents and the scientists based on the fact that it's based on their own system. And you now use the modern knowledge on top of it. Thank you.
Perfect.